Welcome to the DataMagik Script Engine Training Workshop. Our goal is to take you from zero to an automation hero. We'll cover JavaScript basics, the script editor, debugging, and testing safely. Then, we will explore core APIs, script schedules, and real-world examples. There are 16 hands-on exercises marked by pause slides. Prerequisites include a DataMagik account with script engine access and at least one document template. Familiarity with spreadsheets will be helpful, as we'll use analogies, but no programming experience is required. Think of scripts as powerful spreadsheet formulas that can interact with the outside world. Section 2 focuses on JavaScript basics, the language behind your scripts. Variables are like naming a cell in a spreadsheet. Const is for values that do not change, and let is for those that will change. JavaScript has various data types, similar to text, number, or Boolean cells. A good rule of thumb is to start with const and switch to let only when reassignment is necessary. Objects group related data, similar to a row in a spreadsheet with named columns. You can access properties using dot notation, and objects can be nested within each other. Arrays are lists of data. You access items using their index, which starts at 0. Array methods like filter and map allow you to process the data efficiently. You can also chain methods together or use "for each" to iterate over items. An array of objects is fundamentally a spreadsheet. Functions are reusable recipes. Every DataMagik script requires a main function. Helper functions can perform specific tasks. Arrow functions provide a shorter syntax. Remember to always include the function main context, as this is where execution begins. Control flow uses if/else statements, similar to if in spreadsheets, and ternary operators for one-liners. Loops, such as for.of, are used to iterate over arrays or object entries, allowing you to process each item or key-value pair. Template literals use backticks to embed variables in strings. Useful string methods include trim, includes, and split. JSON, or JavaScript Object Notation, is the standard data exchange format. Use JSON.parse when receiving text from APIs, and JSON.stringify for debugging. Async/await handles asynchronous operations, much like waiting for a VLOOKUP result from another spreadsheet. You must add async before the main function and use await before any API call. Always wrap API calls in try/catch for robust error handling. Pause the video for exercise 1, objects and properties. Create a product object with name, SKU, price, and in stock. Log the name and price, add a nested dimensions object, and then log the weight using dot notation. Here is the solution to exercise 1. Notice how we use chained dots to access nested data, like product.dimensions.weight. The return value of the main function is the script's output. Using const ensures the object reference remains the same, even if properties are modified. Section 3 covers the script editor, your workspace for writing automation. The script editor is accessed in DataMagik and has 4 panels: the script library, the code editor, and the settings/docs. The test run button executes the current code, even unsaved, while execute runs the last saved version. The workflow is validate, save, test run, and check output. To create a script, click Create New, enter a name and category, and a starter template will appear. Use validate to catch syntax errors before running, and save creates numbered versions. The docs panel provides a searchable, built-in API reference for function signatures. Pause the video for exercise 4, Hello World script. Create a new script named Training Hello World. Log a greeting using context.name and include the current date and time. Then, return an object containing the greeting. Here is the solution to the Hello World exercise. Notice the use of the OR operator to provide a fallback value for context.name. Template literals allow us to embed variables easily. The returned object is the script's final output data. Debugging uses console.log for standard output, console.warn, and console.error for highlighted messages. Always use json.stringify when logging objects for pretty printing. There are 5 main debugging patterns listed to help you structure your logging. Test context allows you to provide sample JSON input during development. This mimics the data the script will receive in production from automations or schedules. Think of it as a what-if analysis. You can find the test input context in the settings panel and should validate the JSON before running. Test run executes your unsaved current code using the test context. Execute runs the latest saved version using live context data. Your recommended workflow is edit, use test context, test run, check output, and repeat until ready to save. Pause the video for exercise 7, test context in action. Paste in the sample order JSON. Write a script to calculate the line total for each item and the overall order total. Return an object with the order ID and the calculated total. The solution for exercise 7 uses the "for.of" loop to iterate over items and an accumulator pattern to calculate the total. Let total equals 0 if initializes the variable, and total plus equals increments it in each iteration. Pause the video for exercise 8, handling missing fields. Modify the test context by removing the "items" field. Observe the crash and then update the script to handle missing fields defensively. Test to ensure it works with both missing and restored items. This solution demonstrates defensive coding using "context.items" to default to an empty array if the items field is missing. An early return handles empty arrays. Using the OR operator on individual properties prevents crashes when data is incomplete. We are now moving into section 6, focusing on the core script APIs, the built-in superpowers of your scripts. The Fetch API is used for making HTTP requests. Remember to use async for main and await for fetch. Always check response, OK for success codes, as network errors won't automatically throw. Use http.get for simple GET requests. The Credentials API is how you securely retrieve sensitive information, like API keys. Use awaitcredentials.get to fetch a secret. Crucially, never log, hardcode, or return credential values in your output for security reasons. Credential names are typically in uppercase snake case. Pause the video for exercise 9, fetching external data. Fetch user data from the provided URL, check response, OK, and throw an error on failure. Parse the JSON, log the user count, and then log the name and email of each user. Use a try/catch block for error handling. This solution implements the complete fetch pattern within a try/catch block. Checking if response OK, throw new error is critical for handling NON 200 HTTP status codes gracefully. The consistent return object, showing success true or false, helps calling processes handle the result predictably. The Tables API gives you access to lookup tables, acting as a simple, persistent key value store. You can fetch all rows or a specific key. The set method allows writing new data, and get value is used for reading individual values. These tables are great for configuration settings or reference data. The Documents API generates PDFs from saved templates using provided data. The example shows generating an invoice using data from the context. Use Generate Sync to get the URL immediately. Ensure the field names in your script match the merge fields in your document template. The Email API sends emails programmatically. You can specify recipients, subject, HTML body, and the sender's name. It supports sending to multiple recipients and adding features like CC, BCC, and attachments. It's ideal for automating confirmations and notifications. The Scripts.Run API allows modular composition by calling other saved scripts. This enables you to break complex workflows into smaller, reusable pieces. The Helpers API provides utility functions for tasks like safe-nested data access, string formatting, generating UUIDs, and parsing CSV data. Other APIs offer specialized functionalities. Serial generates tracking numbers. Connectors/ZPL handle thermal label printing. ODBC connects to external databases. Shipping provides ship engine services like rates and label creation. Roles in users checks permissions and lists user data. Always consult the Docs panel for reference. Section 8 introduces script schedules, the mechanism for automating scripts on a timer. Script schedules run any saved script automatically. They use cron expressions for flexible timing and support time zones and built-in retries. Creating a schedule involves selecting a script, setting a cron expression, a time zone, and configuring timeouts and retries. This is like scheduling a report, but for automation. Cron expressions consist of 5 fields: minute, hour, day of month, month, and day of week. Each field uses specific ranges and symbols to define when a script should run. This allows for precise scheduling, such as running at 9 a.m. every Monday. Always set your schedule's time zone explicitly to handle daylight saving time. The default timeout is 30 seconds. Set it higher for long-running processes. Monitoring is crucial. The schedule list shows status badges, and you can review the execution history for successes and failures. Remember the common mistake of forgetting to set the time zone. Section 9 brings everything together, covering real-world patterns and best practices. This example shows a real-world order processing script. It includes sequential steps like validation, fetching secure credentials, calling an external API, generating a document, emailing the invoice, and updating the status in a lookup table. The entire process is wrapped in a try/catch block for robustness. Follow these best practices. Always use try/catch for API calls. Log at major steps. Validate input early, and use credentials.get for secrets. Conversely, never log credentials, hardcode keys, skip error handling, or write overly large scripts. Keep scripts small and always test with realistic context outside of production. Pause the video for exercise 16. Build a complete script. Your task is to calculate an order total, look up the customer tier from a table, apply a corresponding discount, log a summary, and return the final order details. Consider adding error handling for robustness. Here is the solution for the capstone exercise. It uses validation, an accumulation loop for the subtotal, a defensive try/catch block for the lookup table, and applies the discount before returning a structured result. This demonstrates several best practices we have covered. To wrap up, remember to practice and use the built-in Docs panel. Start simple, focus on one API call at a time, and review your execution history frequently. Your team and DataMagik support are ready to assist you. Happy scripting! You've gone from zero to automation hero.